All right, so I think this is recording. Let's take a look at these three quadratic equations. Since we do have a middle term here, we want to get these in standard form, in the form of ax squared plus bx plus c equals 0. And then our quadratic formula, which you've seen in every math class that you've had in high school, I believe. All right, so let's tackle number 13. Let's add 3x squared to each side. 3x squared minus 1x squared is 2x squared. Let's add 3 to each side. And 6 plus 3 is 9. So let's identify A, B, and C. And the part of the quadratic formula that's underneath the radical is referred to as the discriminant. And let's go ahead and find it first. That'll tell us the nature of the solutions, and it may tell us if there's no real solution. So, and we have to find it anyway, so we're b squared minus 4ac. Well, b squared is negative 2 squared. Negative 2 times a negative 2 is positive 4. Minus 4 times 2 times 9. And yeah, that's what we suspected, or I suspected. I'm not always that great at mental arithmetic, though. I get a negative 68. So because within the set of real numbers, the square root of negative 68 is undefined, so there is no real solution. In a later skill packet, we do look at complex numbers. You have seen them before in Algebra 2. The square root of negative 1 is defined to be the imaginary unit I, and we can, when we do have negative discriminants, we can have, well, our answers will be complex numbers, complex conjugates, and we'll be able to write them in the form of a plus bi. But for right now, our answer is no real solution for problem 13. All right, so let's continue with problem number 14. All right. So again, we want to get this equation in standard form. I like to put a 1 in front of my variables there for coefficients to just help me identify A, B, and C. If we add 6x to each side, minus 91 is equal to 0. So now we can easily identify A, B, and C. And again, if I find the discriminant, b squared is 6 squared, which is 36, minus 4 times 1 times a negative 91. So let's see what my calculator gives me for that. 36 minus 4 times 1 times a negative 91. I'm getting 400. And I know that the square root of 400 is 20, so I know I'm going to get two rational solutions for this. So let's come in and look at the quadratic formula. We see that it's a fraction. In the denominator, it's pretty easy. You just take 2 times a. 2 times 1 is 2. In the numerator, we have two terms. The first term is the opposite of b. The opposite of positive 6 is negative 6. Then we have plus or minus, and that's just shorthand notation for two equations, right, or two numerators. And we're taking the square root of 400, which we know to be 20. So if we subtract negative 6 minus 20 is a negative 26, and half of negative 26 should be a negative 13. A negative 6 plus a positive 20 is 14, and half of 14 is 7. So if I haven't made any silly arithmetic errors, here are our two solutions. And for quadratic formulas, we're expecting at most two solutions because that degree is 2. Now, you know, again, even in complex numbers, these complex numbers, these imaginary solutions, will come in what they call conjugate pairs. Here, that we have two values. Sometimes you will have within a set of real numbers a root that is repeated. You know, maybe it could have been that x equals negative 13 or x equals another negative 13, and we count that as a repeated solution, a repeated root, and but we still say that equation has at most two solutions. All right, so let's take a look at number 15. Let's get it in standard form. This time I'm going to move the terms to the right-hand side because I like to have, just out of habit, a leading coefficient that's positive. So if I add x squared to each side, if I subtract 3x from each side, and now I've got this minus 54. Let's put a 1 in front of here, and a is equal to 1, b is equal to negative 3, and c is equal to negative 54. See, these are the coefficients. These do not have the variables. A is not 1x squared, a is 1. And I often see students accidentally put variables there, and then they get down here and they don't know how to substitute. If b is negative 3, then b squared is positive 9 minus 4 times 1 times a negative 54. So again, I'm going to go to my calculator. I don't trust my mental arithmetic skills. I get 225. And I think that 225 is 15, or 15 squared. So the square root of 225 should be 15. Yes, and it is. Okay, so we have that x is equal to, by the quadratic formula, the opposite of b, the opposite of negative 3 is positive 3, plus or minus the square root of 225, which we know to be 15. And the denominator, 2 times a, 2 times 1 is just 2. So this gives us two solutions. 3 minus 15 is a negative 12, and half of negative 12 is negative 6. 3 plus 15 is 18, and half of 18 is 9. So these are the two solutions I get there. So I'm fairly confident that you guys are going to be very good using the quadratic formula, just because, I mean, you've seen it so many times. I hope this helps, and I will talk to you later. Bye.